Alright, hey class, as promised, here's the review for this descriptive statistics exams coming up. So unfortunately I lost my little stylus that I have to use to write the notes actually on the screen, so instead I'll just type some things. I have to order me a new one. Anyway, so what I did here is I just sort of outlined what I thought were sort of the major topics that we've covered so far. And you'll see right away that we have covered quite a bit, but nothing really too terribly hard, and I think that we will do pretty well in this exam. So here we go. Measures of central tendency was the first topic that we talked about, and we came up with essentially three of them, right? The mean, let's do this, oops. The mean, median, and the mode. And what's the difference between these three? Well, we remember that the mean is just our sort of regular old school average, what we remembered or what we learned in sort of third grade, where we sum up all the possible things and divide by the total number. So nothing new, we remembered that. The median is that if we sort everybody, from smallest to biggest, it's the one in the middle. Right, so right smack dab in the middle, and we talked about if there's not one in the middle, it's the average of the two. Right, so nothing here, very hard. And the mode was just the one that happens the most often. And when do we use which one? Well, most of the time we're going to use the mean. In fact, really, from the rest of this class, we'll end up using the mean on lots of things. However, for this exam, there might be a time where it might be appropriate to report the median if there seems to be some outliers, or there seems to be something that would really shift the mean, where the mean doesn't seem to actually represent. Again, we're after some sort of central tendency, something that's right about in the middle. We might use the median. So the median home price, that's there so that the sort of the big home sales aren't in there. Just notice this is, if I sort, that's right. Aren't influence the mean. All right. So actually, I was just the other day at band practice. I don't know if I've told you this, but I'm in band. Band nerd. Just to add more reason why you think I'm a complete dork. Anyway, I'm in the band here, the Del Monte Brass. I play the drums, so that's cool. The drums. And one of our tuba players, who's not a student here, but just some local community player guy, just got recruited into some other band, and the band director said, "Oh, that will change the median age." She was just talking the median age. So it turns out she was wrong, right? So by including, she was trying to say that he's really young and he's an outlier, and what she's trying to say is the central tendency will shift. Well, the median isn't likely to shift if I add one outlier, right? That's the point of the median, is that it won't shift if I have an outlier. What she really meant was the mean age will change. I actually corrected her, and she agreed with me. All right, so that's what we got to remember. The mode, then, is not really used a lot for numeric type of things sometimes, but not very often. More often we see it when we're instead trying to describe the most frequent thing that happens. So in our homework, we saw that the most typical person video, most of those were modes, right? We saw that the ethnicity and the gender and the handedness and all that stuff, that was all modes, right? The thing that happened the most often. All right, so think about that. Next one, measures of location or measures of relative standing. So there was really sort of two of these, percentiles and quartiles. And really it turns out that quartiles are a specific type of percentile. And what do I mean by this? Well, if we sort everything from smallest to biggest, and we say something is the 25th percentile. So actually this happens a lot. One of the students came to me and said, whenever I take my son to the doctor, they always report to me his percentile. All right, his percentile. What does this mean, his percentile? So what it means is they have collected data, forever on the size of of specific ages, right? So if you have a 6-month-old baby, they know what the weight of 6-month-old babies, the distribution of the weight of 6-month babies. From all over the country. They've been recording it for a long time. And so they just sort those from the smallest to biggest, and then they put your baby in there somewhere. They're like, well, here's the smallest baby we've ever seen, and here's the biggest baby we've ever seen. And your baby is right here. And that's a percentile, right? We say, your baby is the 90th percentile. What does that mean? Well, that means 90% of the babies are smaller than yours, and only 10% are bigger than yours. Right, so if we say, well, your baby's the 25th percentile, that means that there are 25% of the babies out there are smaller than yours, and the other 75% are bigger. So those are percentiles, and we can choose any kind of percentile, right? Your child could be the 37th percentile, who knows? What doesn't make sense, though, sometimes if they come back and say, well, your child is like the 103rd percentile, that doesn't make any sense. You can't be more than 100%. So don't let your doctor say something like that. Force them to tell you what that means. Most doctors couldn't really explain that, although it's really simple, right? Now that we know what it means. Oh, yeah, that makes sense. But that's all it is. A quartile, then, you could probably scribble some stuff in here. I don't know what to write in here. But a quartile, then, there's really only two, possibly three quartiles. And they are just the 25th percentile is the first quartile. The 50th percentile, or also the median, the 50th percentile, is the second quartile, and then the third quartile is the 75th percentile. And there's nothing really special about those. They just break it up into quarters, right? So there's 25% to the first quartile, and then another 50%, and then another to 75%, and then there's after that there's only 25%. So really we break it up into four parts, hence quartiles. All right. And we know we can do these sort of things in Excel pretty easy with equals quartile, that kind of stuff. And percentile was equals percentile. So nothing too hard here. All right, so those are the measures of location, measures of relative standing, measures of spread. Well, we talked about a few. We said the range. What's the range? Well, the range is just the biggest. Let's see, the distance from the smallest observation to the biggest. All right, so again, 6-month-old babies. I've seen maybe the smallest 6-month-old baby we've ever recorded is I'm making things up now, maybe 4 pounds or something, right? A preemie that's just sort of just starting to get a little bit bigger. 4 pounds. The biggest one we've ever seen is maybe 20 pounds or something, right? So 4 pounds to 20 pounds, making this up completely. 4 pounds to 20 pounds, what's our range? 4 pounds to 20 pounds, what's our range? Well, it's the distance from 4 pounds to 20 pounds. How do I do that? Well, I subtract the max, 20, minus the min, 4, and I end up with 16, right? So it's just the max minus the min. That's the range. And it just tells us sort of how spread out our possibilities are, right, from the max to the min. Well, it could turn out that this min and max are sort of really big outliers. They don't happen hardly at all, ever. So it might not be the best measure of spread, but it is a measure of spread. The next one, then, that we talked about is the interquartile spread. Interquartile range. Wow, that was weird. Interquartile range, IQR. Interquartile range, IQR. And what is the interquartile range? Well, remember, when we talked about quartiles, the first quartile, first quartile is the 25th percentile, and the third quartile is the 75th percentile, and the interquartile range just says, tell me what the range is of that inside quartile, the interquartile, which is in between the first quartile and the third quartile, right? So it's just the third quartile minus the first quartile. And what does this tell us? Well, it actually will allow us to still have a pretty good feel for what the range is, but we'll get rid of any of those outliers, right? So the bottom 25th percentile we don't care about, and the top 25th percentile we don't care about. We just care about the middle 50th percentile and what the range is of that. Because that tells us the range of half of the data. At least half of the data falls in between these 2 points. So the interquartile range. We also found out when we did box plots that is the box, right? That's the size of the box. Okay, interquartile range. The final one then, that was actually the most important, was the standard deviation. Standard deviation. And what is the standard deviation? Well, the standard deviation, we decided to think about it intuitively, is the average distance from the mean of all observations. Of all observations. So what does that mean? Well, that means we first go out and find the mean. See, isn't this nice? When I type things, it will tell me when I misspell them. I can just go like this. Done. Right? None of this weird stuff. All right, standard deviation. I have my original data set, right? Original data set, and I can go and find the mean of that, right? So now we're dealing with babies for some reason, 6-month-old babies, and I can find the average weight. All right, the average weight of 6-month-old baby, 10 pounds. Again, I'm making this up, 10 pounds. All right, but I have all of this sort of data spread out all over the place, and I want to know the average distance from 10 pounds on average. All right, so essentially I go and create a new data set or a new column, a new variable that says how far away are each of those observations from the mean. And then I take the average of that, and that's sort of the standard deviation. Not quite, we talked about this through, that it's really, we have to square that, and then we end up having to take the standard deviation of that average. That's okay. We just want to intuitively know that it's the average distance from the mean of all observations. And that's good. Like, we can get that in our brain. That's what the standard deviation means. It's just the average distance from everything else. And it's important because if that number gets bigger, then we say, well, the data is more spread out. If that number is really small, then that means everything's clustered around the mean. Everybody's really tight, close to the mean. All right, so if I say the average weight of 6-month-old babies is 10 pounds with a standard deviation of, I don't know, like 2 ounces, then what would I say? Well, that means everybody is really close to 10 pounds. But if I say the average weight is 10 pounds and the standard deviation is 2 pounds, wow, now I have sort of really big range, a really big spread out data. So this is what I mean. This is why it's important to understand standard deviation. And in the future, we're going to use this intuitive understanding of standard deviation to actually show that the probability of things happening is outside the realm of sort of reality, outside the realms of probability, I should say. So it's important to understand what it means. How to calculate it, not that important because we're just going to let Excel do it. Really easy in Excel. The calculation isn't that hard. We did it in class, but there's no worries. Why should we do it? Let's just let computers do it. That's why they're around. So let's do that. So we remember the formula for that is equals stdev, something like that. Or you could do stdev.s. So I'll tell you right now that in the exam, you will never see the .p, which is for the population. When the exam will not be population data, will it? No, I don't know. I don't think it will be population data. I'll just tell you. Let's just use the sample data. Okay, so that's good. All right, moving on. So those are measures of spread: range, interquartile range, and standard deviation. The big guy, standard deviation. There's also variance, but variance is just another. Is just the squared of the standard deviation. So really the same thing, and is not as interpretable, not as easy to use. Rules of spread. So we had 2 rules of spread. The empirical rule, and Chebyshev's theorem. Wow, look, I spelled both of those wrong. Theorem. There we go. Theorem. Chebyshev. Yep, we don't know how to spell Chebyshev. That's all right. I think there might be an H. Nope. Chebyshev. That's all right. So what are these 2 things? So the empirical rule, so this is the point where it would be nice if I could draw. Let's try doing, I can draw with the mouse. Let's see how well that goes. Review. Here we go. All right, so the empirical rule says that if I have some distribution of data that looks like a bell, and we're going to, oh, that was bad, but it turns out this is called the normal distribution. The data is normally distributed. Pretend like this was more bell-shaped. Draw yours better. Bell-shaped, where it was symmetric. Remember, symmetric means the same on both sides. And we would say, okay, well, the mean value is like right smack dab in the middle. And we'll say, let's just make up again. We'll play with our same little thing with the babies. And we'll say the mean weight of babies is something, what did I say? It was 10 pounds. 10 pounds. This is for 6-month-olds. I'm making this up. No idea. 10 pounds. And then we could also say that the standard deviation, which we say is S for sample, or sigma for population, but let's call it S because we're dealing with X bars, which is a sample. Standard deviation S. Let's go ahead and just to make the math easy, well, let's just let's just make it 1.1 pounds. Right. So far, one thing to remember, everything I've done so far has always been really simple math, integers, right? I've never had to do decimals. In the homework, we found out that it's completely okay to have decimals, right, for standard deviation and for z's. Remember, we did some z-score stuff. All right, so what does this mean, empirical rule? Well, the empirical rule says that if, again, the mean here is 10 pounds, that if I go, well, one standard deviation away on either side of the mean, oh man, look what just happened. I don't know what happened. Yeah, he just moved. Oh, there he is. Either side of the mean, then I can assume, say this is this right here is 11.1. And then I go one more standard deviation. If I go this way, then let's see if I can figure out the math. 8.9. Don't get mad at me if I screw up the math because I'm doing it on my head. And then if I add one more standard deviation this way, then what do I get? Well, I just add 1.1, so that's 12.2. 12.2. Oops. And then if I add one more standard deviation, I kind of go out here. I'm trying to make these equal size. One more standard deviation. It would be 13.3. 13.3. Okay, let's go this way. Let's see if I can do the math backwards. If I subtract 1, then I end up with 7.8. Then subtract 1.1 again, I end up with 6.7. Is that right? 7.8, 8.9, yeah, I think I did the math right. So this is 10. So what does this mean? Well, the empirical rule then says that this first standard deviation from here to here is, I have to look at my notes, 60-something%. It's in your notes. Oh, I don't want to screw this up. See, good thing I've been here. Don't worry, I'm almost there. Nope, don't worry. Here it is, 68%. Exactly 68%. This is why we have notes, is because who really remembers this kind of stuff? 68%. What does that mean? So the 68% isn't a 68th percentile, so don't be confused by those two things. 68% is different than 68th percentile. The 68th percentile means that there's 68% smaller and 32% bigger. 32, yeah, something like that. 68% means that of all the observations, of all the babies, 68% are between 8.9, one standard deviation smaller than 10, and 11.1, one standard deviation bigger than 10. 68% of all babies fall between there. And then we also saw, it goes a little further, come on, that if I go 2 standard deviations away, 2 standard deviations, that's my blue line, then it was 95%, right? So in blue, 95%. And let's change colors. If I go even further and go 3 standard deviations, it was what, 99.7%. 99.7%. Okay. So what does that mean? Well, that means that if I had a baby that came out that was 6 months old that was greater than 13.3 pounds, again, these numbers are all made up, so don't freak out if you have a 6-month-old baby at home that's bigger than 13.3 pounds. But if these were the right numbers, and they were greater than 13.3 pounds, that should only happen about 3 in every 1,000 babies. 3 in every 1,000 babies. The other 997 babies should be smaller than that, but not any smaller than 6.7. All right, so if I have a baby smaller than 6.7, then again, that shouldn't happen very often. And this is what the empirical rule says. If my distribution, if my data is bell-shaped or normally distributed, it turns out that that happens a lot. And later on, we'll find out that if we take samples of things and the average of samples are normally distributed. We'll get to that. Don't worry about that. The empirical rule, though, is important. Part of the empirical rule is calculating a z-score. So actually, I'm going to just switch over to typing. So part of the is a z-score. I didn't have this in the notes, but we got to figure out what a z-score is. What is a z-score? It's the number. Let's see, the number of standard deviations away from the mean. All right, that's all it is that an observation is. So if I had a baby, let's look at our graph. If I had a baby that was 12.2 pounds, how many standard deviations away from the mean is he or she? Well, exactly 2 standard deviations away. Exactly 2, 12.2. Now, what if I had a baby that was like 11.7 ounces? 11.7, so that's like in between here somewhere. How do I calculate the actual standard deviation? 11.7. How many standard deviations away? I should know, just by looking at this, that it's between 1 and 2 standard deviations. It's like 1 point something. 1 point something. I don't know, 1 point something. So there's actually a pretty easy formula to figure this out, right? And it's just, we just take our mean, x bar. Actually, nope, it's our variable, x. I always see this wrong. X minus x bar. Right? And then all of that, I divide. It's going to be easy, like ugly. It's going to be ugly, but that's right. I divide by my standard deviation. Standard deviation. X minus x bar standard deviation. That will give me the z. So if I were to calculate this out, let's see. Let's find out. Get my calculator going here. Here it is. All right. So my x, if I said I had a baby, what was 11.7 ounces? 11.7. And subtract my x bar of 10, end up with 1.7. Then if I say I wanted that divided by 1.1, 1.54. What is 1.54? What? 1.54 standard deviation. So z score is the standard deviation. So the number of standard deviations away. Got it. Okay. Z score. So we're good there. Chebyshev's theorem. So Chebyshev's theorem is essentially the same thing, except for that it will work for any distribution. And it becomes even easier. In fact, we say something that, I got to look at my notes, at least, these are in your notes, 1 minus 1 over k squared. Ooh, squared. How do I make a squared? Squared. Oh, man. Of the items in any distribution fall within plus or minus k standard deviations. So fall within plus or minus k standard deviations. And k doesn't mean anything. It's just a variable in this case. Standard deviation. I'm going to write it that way. All right, so this is essentially kind of the same idea, but it will work for any distribution. All right, so really, we could do some calculation. We did this in class. Look through your notes if you want to look through that one more time. I'm not going to work through an example. All right, so Chebyshev is very similar to the empirical rule, but it will apply to anybody, any distribution. All right, so next one, measures of relationship. The big one here was correlation. We also talked briefly about covariance, although we never really figured out how to do it or what it was good for, but we know that that is a measure of relationship similar to covariance. What do we mean by measures of relationship? In this case, the relationship of 2 variables. So up until this point, we just talked about 1 variable at a time, or one type of observation. Now we're going to say, well, here's 2 measures, 2 variables. I want to see if they go together, right? And what do we talk about? Well, correlation does 2 things. It gives us the direction of the relationship. How does it do that? Well, that's either plus or minus. Plus or minus. So that's either a positive relationship or a negative relationship. Positive meaning if one goes up, the other one goes up. Right? So let's talk about height and weight for 6-month-olds. That makes sense. So if my weight of my 6-month-old goes up, I would also expect my height of the 6-month-old to go up. So that is a positive correlation. I don't know if I can think of a negative correlation. For babies. I can't really think of one right now. But we can think of one, maybe the amount of sun in Monterey and the amount of fog. As the amount of sun goes up, the amount of fog goes down. Right? That's a negative correlation. We'd end up with a negative correlation coefficient. So that's the first thing, direction of the relationship. The second thing, then, is the strength. And remember I talked about that the strength has to do with close, we say that it's stronger relationship if it gets closer to 1 or closer to -1. Our range of correlation is only between -1 and 1. If it's close to 0, then we say that that is not a strong relationship. There's no cut and dry that says, if it's bigger than this, it's a strong relationship. But we can compare two correlations. Right? So I can say the correlation of height and weight for 6-month-olds is, 0.65. The correlation of height and weight of 18-month-olds is like 0.85. I'm making these up. But then I would say 0.85, 0.65. 0.85 has a stronger relationship than 0.65. So I can compare these across one another. So generally, though, what I've heard is, if it's, or what sort of the way of thinking is that if the number is sort of, again, close to maybe 0.75 or higher, or negative 0.75 and smaller, that's a pretty strong correlation. That's pretty good. All right, and then again, if it's like, down by 0.25 or lower, or closer to 0, negative 0.25 and bigger in between there, that's a pretty poor correlation. In the middle, it's kind of moderate. Right? Nothing really strong, nothing really weak. There seems to be some correlation, but nothing outstandingly strong. All right, so it's correlation. We found two ways to do this in Excel with the equals Correl function, or we could also do the correlation matrix if we want to do a whole bunch of correlations all at once. All right, so correlation. Look, I spelled variables wrong. Let's fix it. All right. Types of data. Types of data. So we, what do we have? We had this sort of nominal data, continuous data, and ordinal data. What were these three? Nominal data, sometimes called discrete data, categorical, another way it's called categorical data. Continuous data is more sort of numeric, although nominal and ordinal can also be numeric, so be careful here. But nominal data is the easiest one to remember. Is it's a category. We're going to put things into categories. Right, so there was plenty of nominal data in this first set of homework that we did, where we had let's list some nominal data, like the branch of service. It was nominal. It was categorical. What if you had an iPad or not? That's data, categorical. What type of computer you use, that kind of stuff. Continuous, though, we should call it continuous because hypothetically we could actually measure things so precisely that I can get a really good measurement device, a really exact ruler or a really exact scale, and I could get out to lots of decimal points. Realistically, that's not the case for all continuous data because it just doesn't make sense. But it's called continuous data anyway. Numeric data is kind of an easier way to think about it. And it could include like counts, like so we said how many siblings do you have. That was kind of continuous data because the distance between one sibling and two siblings and three siblings, those are all the same. We always know how far apart each things are from one another. Okay, so ordinal data, we haven't really played with any ordinal data, but it's essentially the rank, right? The rank of a specific person or thing. And we don't know the difference between the first ranking and the second ranking, and the second ranking and the third ranking, that very likely are very different. So that's a rank. So let's see, rank data. All right, so those are types of data. Different types of data, we do different things. Nominal data, we're mostly going to just be after sort of the mode. And we want to sort of maybe see a distribution of things. We can use a bar chart to display nominal data. And we can find, within nominal data, we can find maybe the mean of some other variable. So we did that at some point, right? Like I wanted to know the mean sleep, or the sleep time. Sleep time is a continuous variable, but I want to know the mean sleep time of people who own tablets, right? And so I had this nominal data, and within the nominal data, I used it to separate my other data and find the means, and then that way I can sort of tell a story of some case. So sometimes I'm going to use these data as sort of interrelated. Continuous data, though, I can do the mean, the median. I could do the mode as well if it makes sense. I can do standard deviation. I can do all that stuff. Ordinal data, a little bit harder to do just about anything. Really, all I can do is sort of rank the data, treat it essentially like nominal data. I can maybe chunk it up and say, well, here's the fifth, the first five ranked people through a race, or the first 5 ranked something, what's the average something else, like the average continuous data of the first 5 people. So I can use it like nominal data. Great, so those are types of data. Charting, what do we do? Well, so you're working on some homework, or maybe hopefully got a good start on it. There are a few things you got to know how to do: a bar chart, a histogram. Let's see, a scatter plot. A line chart. A line chart uses time on the bottom. Line chart, very similar to a scatter plot, but just with time, things going over time. We talked about a box and whisker chart. Whisker, nice chart. But I don't expect you to be able to make one of those in Excel. They're a little bit tough, but go at it if you want to give it a try. There's some videos out there. So I think those are these 4. If you can do these 4, you are going to do all right. Scatter plot, line chart, histogram, bar chart, pie chart. If it's okay. We talked about how sometimes pie charts are not that great, but let's figure out how to make them anyway. So the thing about charting that that's my big thing is to make it clear what's going on here, right? Don't add a bunch of extra stuff unless it makes sense to add the extra stuff, and let's just make it visually appealing as best as we can. So watch the video I made. I did a few things that Excel that will allow you to do, but it's not the default, to make stuff look a little less lame. Excel default Microsoft visual things are kind of lame, and so let's go to fix them up a little bit. All right, so that's data visualization too. Essentially what I just talked about. We didn't go into depth about it. It probably won't show up a lot on the exam, but there is some cool stuff on data visualization that you feel free to go take a look at some of those videos. One thing I do want to mention, I think I've said it a couple times already, though, is that video that's in the data visualization part of my website. Let me pull up my website, and I'll show you where it is. Let's see. Nope. Faculty. There we go. Faculty.mps. Oh, gosh. Faculty. Here's my website. So faculty.mps.edu/mjdixon. Go to managerial statistics, descriptive statistics. Nope. Data collection techniques, visualizing data. This guy down all the way to the bottom. This, it's an hour long, 59 minutes and 13 seconds, is an excellent review for the exam. Probably way more thrilling than this. So watch it. It's worth it. So watch that. Joy of Stats. It just has a great title. Joy of Stats. So watch that. Next, data collection techniques. So we just barely got done talking about this. So I'm not going to go into depth too much about it. But we basically came up with 3 ways that data are collected. All right. So observational data. We would basically call these different types of data: observational, survey, and experiments. Remember, there's advantages and disadvantages of each of these. And you should kind of be familiar with what the attributes of each of these are, how to actually identify what each of these are, and to know that we can think about a specific study using maybe all 3 of these. Right? There's a possibility that I could use all 3 of these types of data for a specific study or specific question that I'm after. So the big part, though, that came up was sampling. So we have to make sure that our sample is not biased. Right? And there's a whole bunch of ways to make our sample biased, and we talked about several of them. So review some of that stuff and make sure you got all of that. Not biased. So what else did I want to talk about? This is kind of the end of my sort of thoughts of what we've covered. So final note. The homework 1 you've done really well on. You notice there's sort of 2 parts of homework 1. There's kind of the quantitative, the answer is right or wrong, and then the several other questions that I've graded, some of them but not all of them, of your sort of fill in, write a few sentences. So what am I looking at for those questions? I had a couple people come in and talk to me about them. I'm pretty loose on those for the most part.
there's multiple interpretations of things, right? Especially when I say, okay, interpret. Let's talk about the very last question where I said, find what you thought was the most average typical student. Well, there's a ton of different answers for that. As long as you can justify what you did with the numbers, I'm happy with it. I'm like, that's cool. I don't think there's a right answer or a wrong answer. There's sort of maybe more right, or maybe the way I would do it, which doesn't mean it's more right, but it's just the way I would do it. But if you can say, look, this makes sense to me, this is the way I would do it, really what I wanted you to do in that assignment was to get your hands in the data and start playing with it. So for the exam, it's the same way. Like, I just want you to sort of be playing with the data and coming up with some interesting results. There might be something like that where, pretty likely, where I just say, just go at it and do something and tell me what you find. All right? Like, I'm not looking for anything particular. I'm not looking for the right answer. I just want you to show to me that you played with this data and found something that was kind of cool that you maybe didn't expect, or maybe you did expect it, but look, the data is just really, here it is. This is what the data says. So that's just going to get us practice getting into data and start playing with stuff. So that's the first one, first thing I want to mention. I try to give you some hints. The one question that several people didn't kind of get the full credit on was the one where there was a really small correlation between finger spread and height, which should have been bigger. Essentially, I kind of gave you hints. Look in the data. There's something wrong. Turns out there was essentially a typo in the data. Instead of 24 centimeters, I put 2.4 centimeters. And that was what I was looking for. I want you to actually look in the data and say, why am I getting the answer I'm getting? Why is this answer that doesn't seem intuitive, that doesn't seem quite right? Why is it the way it is? So, I mean, I'll try to, if I have a question like that, I'll try to sort of lead you down the right path. And hopefully that doesn't frustrate you too bad. On the other hand, if you can fully justify, your answer to some degree, I'll give you some points on that degree, on your efforts. So, what else? Yeah, so Excel. So make sure if you're brand new into Excel, give it some more practice. Even if you need to sort of come up with some fake questions on the first assignment. I just keep playing with it and come up with some different things, some different combination of questions, similar to the ones that I showed you. All right, try to find, the one that says, okay, now let's get crazy. Do some more of that. Try to see some more crazy stuff. Play around with the data. Play with some pivot tables if that's helpful. If you're stuck in pivot tables and you just can't figure out pivot tables, you probably could have done the entire assignment without them. So don't get too hung up on that. If you can't figure out pivot tables, it's not the end of the world. Just know how to sort of sort data so that you can make sure you're looking at just the right type of data before you put your answer. And if it helps, go watch some more of those. Go watch the Excel bootcamp some more. If there's a specific thing that you're just not quite getting, send me an email. I'd be happy to help you with that. All right, so I think that's about it for this review. I think you're going to do really well on this exam, so don't freak out about it too much. Do give some time, reviewing stuff. Give that second assignment your best effort. Do really well on that so that you're just gung-ho ready for the exam. You will have to make some graphs in the exam. So make sure you know what you're doing there. It's not going to be anything different than what's already in assignment 2, but you just got to be able to do it again with different data. Make sure you know what's going on in assignment 1 and that you're able to do it by yourself, if the questions came up. Maybe one strategy would be to have some partners that you're working with to come up with questions that you could answer in assignment 1 with that same data, and then you guys just come up with different questions and then kind of go at it and attack what the answers would be. Just get some more practice doing that, and you'll be fine. All right, so I will see you guys a little bit later, another week or so. So best of luck on everything, and please, if you have questions, don't hesitate to email me, and I'll respond as quickly as possible. All right, see you later.